Hello, welcome back. This is exercise 8 for the homework 7. For this question, we are going to find the expected value of random variable xt and the r t1, t2, right? So firstly, it gives us that how to define Poisson process. So by the definition 1, we could know that the random process xt is equals to n. Let me change color here. n0t. That is by the definition 3. So from the Poisson distribution, we know that the sigma, the sum of this is equals to 1, right? So we multiply the e with the power of lambda both sides of this equation. We could get this step, and then we take derivative to the lambda here. So here, yes, take derivative to the lambda. So there should be k times lambda with the power of k minus 1, and here that is factorial of k, and the k factorial, that it should be k minus 1 factorial, right? So then we multiply k to the denominator and numerator. So there should be, this step. K times lambda with the power of k minus 1 over the factorial of k equals to, the sum of this equals to e with the power of lambda. And then we take e lambda back to the left side. I could get this. This is the expression of Ex, right? That is the Poisson distribution, and the expected value of x is equals to lambda. And now we know that the Poisson process is, this is a Poisson process here. By the first definition, we could know that if we just replace the lambda with lambda t in the Poisson distribution, we could get the expected value of Poisson process. So the expected value of Poisson process is equals to lambda t. That is for the first question. And for the second question, we have two situations. The first is that t2 is larger than or equals to t1, and the second is t1 is larger than or equal to t2. With the let me see, definition 3, is this 3? Yes, 3, we know that xt equals to n0t here. So it equals to xt1 minus xt t0, right? I think there should be 0 here. And the second one is, that is, let me write like there is t1 and t2, right? t2 is larger than or equals to t1, and this time interval equals to here, and here the next interval is equals to xt2 minus xt1 here. And by the second definition, second characteristic of Poisson process, that if these two interval, that is interval 1 and interval 2, if they are non-overlapping, then these two random variable and of this interval and this interval are independent. So these two are independent. So we could use the formula here, that is this is equals to the expected value of xt1 times xt2, and xt2 equals to, not equals to, we could use xt2 minus xt1 then plus xt1. The equation does not change, right? And then we take all this stuff out of the parentheses. So, and they are independent, so we could write the expression as this two expected values multiplication and the square of this expected value of xt1. And so based on this, we need to know the expected value of x squared, right? And then we could get the expected value of the portion process of xt squared. So we firstly know that from the previous step, and then we take derivative to lambda, so we get this step, and then we times e minus lambda for the both sides of this equation. We could get 1 plus lambda times lambda. That is here, that is the expression of the expected value of x squared. So x squared is equals to this. Then we know that the portion process expected value of xt squared is equals to this, right? Since we just changed the here, that is lambda, and change it to lambda t, so we could get this expression. And for the step 1, that is here, is equals to, we take it back to this here. The first one, y is lambda t, that is for the previous question, we get that the expected value of xt is equals to lambda t, right? So here we could just write lambda t1. And the next one is also a expected value, so that is for the interval of t1 to t2, so that is t2 minus t1 and plus the square of the xt, so that is what we just calculate there, and the final result is equals to this. And for the second situation, that is t1 larger than t2 or equals to t2, that is the same, right? We just change the order of t1 and t2, so we change t2 to t1 and t1 to t2. Here we could get this expression. So I think that this is enough for this question. Yeah, thank you.